Guess where we went this weekend?
I don't know. Outer space?
Funny, Dr. D. We went to the National Air and Space Museum.
Oh, did you see the Wright brothers plane?
Yeah, it was so cool.
Well, did you note after the last flight, a gust of wind came up and sent the Wright brothers flyer tumbling across the sand?
Is that why the Wright flyer never flew again?
That's right, because it was damaged.
Today, planes are built much differently. When we went to the museum, we learned about the 4 forces of flight.
What are the 4 forces of flight?
Let's see. There's lift that pushes a plane upward.
And weight, which is Earth's gravity pulling down on a plane.
Then thrust, which is the power to push a plane through the air. Oh yeah, and drag. Why do you think it is important that we must understand all 4 forces?
I'm not sure. I would guess you have to have all of them to make a plane fly.
Yes, they're all connected to each other. For example, changing the thrust also affects the lift and the drag. We must first examine them individually before we can see how they're related to each other.
Can we start with the force of lift?
Sure. What part of the plane do you think provides the lift?
I would say the wings.
That's right. The wings are designed to push air downward. The air flowing over top of the wing and the air flowing underneath the wing are both bent downward. These fan blades are just like a wing. Look at the blades. See how they're angled?
Yes, why is that?
Well, the blades are angled upward from the direction of motion. This angle allows the blades to push the air downward.
How do airplane wings compare to fan blades?
As the fan blades spin, they cut through the air like an airplane wing. Take a look at this airplane that I got many years ago. Notice how the wing is slanted upward with the front edge higher than the back edge. Turn on the fan now and see what happens.
Those fan blades are pushing a lot of air.
Well, how can we increase the air pushed down by the fan?
It could spin faster.
Indeed. A faster spinning fan blade is like an airplane wing flying through the air faster, pushing more air down.
Why does a wing need to push air down?
It's what provides lift.
I don't get it. How does pushing air down create lift?
Well, Sir Isaac Newton said, for every action, there is an equal and opposite reaction. It's called his third law.
So that means when the wing pushes the air downward, the air is pushing up on the wing?
Correct again. Let's try an experiment. Tip the fan up like this and put it on these skates. Now the fan's going to push the air this way, that's the action, and the air's going to push the fan the other way, that's the reaction. All right.
Wow.
I bet the problem with our airplane last year was that we didn't have an angle on the wing. If we don't have an angle on the wing, we can't push the air downward and get an upward lift. We need to angle the wing up, and it would work better.
I can't believe that the air would push up on this model plane and give it lift, but it's hard to believe that air can push up and give lift to something as big as those passenger jets. They do weigh a lot more, but I guess their wings are a lot bigger.
Well, it's almost like magic, but it's real science. To really understand lift, you need to visit a wind tunnel. Why don't you contact Luther Jenkins over at NASA?
Wow, this is really neat.
Have you ever seen a wind tunnel?
I've never been in a wind tunnel, but I've seen them on TV.
Well, this is one of 30 wind tunnels we have here at the NASA Langley Research Center in Hampton, Virginia.
We found at the National Air and Space Museum that the Wright brothers built their own wind tunnel in 1901. They collected data from that wind tunnel and built a successful glider.
That's absolutely correct.
What do you use wind tunnels for?
Well, like the Wright brothers, we use wind tunnels to examine how the air flows over different objects, like planes, cars, wings, and even tires. This helps us understand how they will perform and gives us insight so we can develop new designs.
Is there anything you can show me?
Well, Dr. D showed you how the angle of a wing actually deflects the air downward to create lift. I'm going to show you how the air flows over a wing. This is a different way of looking at the concept of lift. Come with me.
Okay. What do you mean to show me how the air goes over the top of the wings? We can see air?
No, you really can't, so we use smoke to visualize the air. Can you see how the smoke particles that strike the front edge of the wing, some travel over the upper surface and some travel over the lower surface?
It looks like the smoke is going faster over the top of the wings.
You're right. The curvature of the upper surface actually causes the smoke particles to speed up or travel faster over the upper surface. The force applied by these faster moving particles on the upper surface is lower than the force that is applied on the lower surface by the slower moving particles. The difference in forces actually creates a lift and causes the plane to stay in the sky.
That's weird. I wonder how big airplanes stay in the air. I mean, they're so large.
That's true, they are very big, but they also have large wings, and the air has more surface area over which to travel. That generates more lift and allows them to stay in the sky.
Why is it important to test airplane wings?
Well, we test airplane wings so engineers would know which ones to use for their particular design or application. That saves time and money.
That was so cool. I think it was so interesting seeing how the smoke went over the wings.
Well, I hope it helps. I'm sure you do well in the contest.
Thanks.